In this video, we are going to go over conjugate acid-base pairs. An acid and its conjugate base, or a base and its conjugate acid, are collectively called a conjugate acid-base pair. You can see here that acetic acid donates the hydrogen to water, so water takes this hydrogen, water becomes a hydronium ion, and acetic acid loses its hydrogen and becomes an acetate ion. When an acid loses a hydrogen, it becomes a conjugate base. The acid and the conjugate base constitute a conjugate acid-base pair. A base and a conjugate acid are also a conjugate acid-base pair. Only certain hydrogen atoms can be donated in a molecule, and they are referred to as the acidic proton. They're usually indicated by placing them at the beginning of the molecular formula. So for hydrochloric acid, we have HCl, and the hydrogen, the H, is the acidic proton. For acetic acid, you can see that it's HC2H3O2. We don't have C2H4O2. We don't combine the hydrogens. We have a hydrogen in front, which shows us that we can donate one hydrogen and make the acetate ion. So determining the formula of the conjugate base, you start with the formula in charge of the acid. So this is our starting point of an acid. We have HCl. You subtract one hydrogen from the acid. So if we take the hydrogen away, we're left with Cl minus. Well, you decrease the charge by 1 unit to make it more negative. So HCl was neutral, so we go down 1 to a -1. For H2PO4, this is our acid. To get the conjugate base of our acid, we remove, so minus a proton. So we're down to 1 proton. We only have 1 H, so HPO4. We are at a -1 charge, so we're going to move down 1 more charge, decrease it by a negative charge. So now we go from -1 to -2. To determine the formula of the conjugate acid, you start with the formula in charge of the base. So HCO3 minus is our base. You add a hydrogen to the formula to make H2CO3. And you increase the charge by 1 unit to make it more positive. So we went from a -1 plus 1 goes to 0. So our conjugate acid of our HCO3 minus is H2CO3. We added a hydrogen and we increased the charge. So to practice, we're going to look at the equation and we are going to label the acid, base, conjugate acid, and conjugate base in each reaction. Let's go ahead and pause the video, and then when you're ready, come back and we'll check your answers. So in this first equation, you are going to look at the 2 species on each side of the equation that only differ by 1 hydrogen. So we have H2SO4, H2O goes to H3O plus, HSO4. We have H2SO4 and HSO4. They differ by 1 hydrogen only. And H2O and H3O plus differ by 1 hydrogen only. Those are our 2 conjugate acid-base pairs. Now, in order to determine the acid and base, we need to see which reactant donated their hydrogen. Which one lost a hydrogen? We see that H2SO4 went to HSO4 minus, and H2O went to H3O plus. H2SO4, so sulfuric acid, lost a hydrogen. It donated a hydrogen. which means it was the acid. It donated hydrogen to the water, so therefore the H2O is the base. So this is our acid, this is our base. The conjugate base pair, conjugate acid base pair, so if our acid is H2SO4, then HSO4 is our conjugate base. And if our base is our H2O, then H3O plus is our conjugate acid. For this following one, we have HCO3 minus and plus water goes to OH minus and H2CO3. So we have HCO3 minus goes to H2CO3, and H2O goes to OH minus. We see that HCO3 minus adds a hydrogen when H2O loses a hydrogen, which means that water donated a hydrogen, so it decreased in hydrogen, so it donated a hydrogen, which means that water is the acid. It donated the hydrogen to the HCO3 minus, which means that this is the base. The conjugate acid-base pair means that the base, its pair is going to be a conjugate acid, and the acid turns into the conjugate base. So in summary, an acid and its conjugate base are a conjugate acid-base pair. A base and its conjugate acid are a conjugate acid-base pair. The conjugate base of an acid has one fewer hydrogen atoms and a charge 1 unit more negative than the acid, and the conjugate acid of a base has one more hydrogen atom and a charge 1 unit more positive than the base.